Thank you for having me. Very happy to be here. This is one of my favorite events. So it's virtual this time. So we're all doing things a little different. And we will, I think this will be great. So looking forward to having some questions at the end. So if you have any questions, please let me know. But this talk is about distributed tracing. And I am Dave Nielsen. You can reach me on Twitter at Dave Nielsen. And okay, and I'm getting a hello from someone. Hello. And I'm the head of the Hypertrace community. I work at traceable.ai. We are the company who created Traceable. And prior to this, I worked at Redis Labs, heading up the community there. I also worked at Intel for a short stint. And a long, long time ago, I was at PayPal when we first launched their APIs. That's a long time ago. Again, you can follow me at Dave Nielsen. And you can also check out more talks and things like that at hypertrace.org. All right, so our agenda, we're going to talk about distributed tracing. It's sort of observability is now the cool term, but they are slightly different. Distributed tracing is really a part of observability, but I think it's the most important part. But what you're trying to do basically is see what's going on inside your application. We'll talk about how telemetry relates to that. We'll give you some examples of metrics, logs, and traces. And again, we'll kind of get further into the details about what is distributed tracing, why you should care. I'll do a quick introduction to Hypertrace, which is what project I work on, and we'll use it to demo distributed tracing. Hopefully the demo gods will be pleased. And I'll share some further resources. And we also have a special offer. So right now our project is relatively new. We just launched it a few months ago. And we're still in that phase where we're willing to help people get started with their own application. So we have some help we can give you to actually help you instrument your own application so it can take advantage of distributed tracing. I'll tell you more about that later. Okay, so first of all, let's get into observability, why and what. So there's this great quote. It's monitoring tells you whether a system is working. Observability lets you ask why it isn't working. Gives you a little bit more data, a little bit of telemetry to help you see more about what's going on inside your application. So first of all, let's back up a little bit. Why observability? So let's just say you're starting your business and you're building your first application. You're probably not going to start off with a microservices-based application. You'll start off with a monolith. But over time, as your business matures and you grow, then you'll start having challenges with a monolith-based application. There's many reasons for this, but you'll end up moving towards microservices probably. Now, the biggest benefit you get from a microservices-based application is that your teams can work independently. So if your application has grown very large and maybe you have different services and maybe different groups or divisions within your company that need their own features and deployment schedules, then your teams can work independently and deploy their microservice or services independently of other teams. This is a big benefit. You can also have some additional benefits like scaling out your application, different services differently. You can use different programming languages, but in my experience and from who I've talked to, the biggest benefit really is that your teams can work independently. But this actually introduces complexity. So microservices, by their very nature, are distributed, and that can create a lot of complexity. So it can be a challenge. And one of those challenges is that while in a monolith, you build an application, and when you see a failure, when you're building your application, you see a failure, it's like a stack trace or something like that. And you're basically seeing everything, or you have access to the logs or all of the metrics for that application at one time, and you can see really everything about that application at that point in time. But with microservices-based applications, you have different services spread out, and they're calling each other. There may be multiple layers of services, and when you call each one of them and get an error message back, you may not know which service actually generated that error. And so that creates some complexity. You only get perhaps the error messages from the service that you called, not the ones that it called. So you don't necessarily know what happened. But distributed services help you with that, or observability can help you with that. So one of the biggest problems that you have is the unknown unknowns. So something may be running slow and you aren't quite sure what's causing it, or maybe something's happening. There's some race condition or something, and you don't really know it's even happening at the time. But so there may be opportunities to improve things as well. So there's a lot of possible unknown unknowns, and so that's another thing that you might struggle with in a distributed application. So, and there's also this rise of the API ecosystem. So with APIs, you've got a lot more services that you're calling. Your company is maybe dividing up their applications into services that they provide to other applications. So you might have a team, for example, handling all of their accounting for your different users and login privileges and whether or not that service is for a premium customer or not, and they handle that for all of the applications. And so that's not really part of your application. You're consuming that service from another department or team within your company, and so that's now creating more complexity as well. And monitoring really can't help you beyond your service, so you're limited in that respect. Okay, I like to show this. This is the Death Star diagrams that you sometimes see. They've been around for quite a long time, but they're a great way of explaining how complex these services can be. In large companies, you can have thousands of services, maybe even tens of thousands of services. And so the whole thing as a whole is more like a mesh or a fabric, and the one particular service might actually treat itself as if it's a service, like a SaaS offering to many users, and so it needs to maintain versioning and all that kind of stuff. So this can, in fact, I would say that most companies' services aren't even this organized. This looks complex, and most companies who are big are even more complex. So again, what is observability? So there's this control theory. In control theory, there's this concept called observability, which is defined as the measure of how well you can understand what's happening inside of your application based on the application's outputs. So it's really, how can you see all that? And the way the typical data that you will use in order to, or access in order to see what's happening, will be metrics, events, logs, and traces, which spells out MELT, which makes it nice and convenient. Let me get rid of this chat window over here. Oops, hold on a second. Okay. And hold on, I think I might have just gone back one. There you go. All right. And so observability it takes advantage of these data points to help you understand what's happening. And there's a lot more to it as well. And so, for example, you might want to understand what characteristics led to your query timing out. Was there a new service version deployed? Is there some browser plugin, or maybe an overloaded database? So that's really important for you to be able to see all this, and observability can help you with that. And how does this all occur? Well, your application produces the data, but you need to collect that data. And so you collect it with instrumentation, and you add some code or an agent to your application, and it sends it to a server that collects all this data, and then you can query that data to answer questions or discover the questions that you need to be asking. Now, telemetry data aids observability, and telemetry data is really what data is used for in distributed tracing. It's not observability itself, but it is generated by instrumentation code, It describes the events in the system. So every time an API call is made, and it gives you a view of the underlying truth of what's happening in your application. So you may be viewing or experiencing some delays. Your users may be experiencing some delays, but you can then get down into the truth and see what service or what API call is actually causing the problems. Okay, so let's talk about metrics, logs, and traces, the components. So metrics are the aggregated summary statistics. And it's not everything generates metrics, but most everything does. So this is probably the first place you're going to look to get your data. And it usually includes things like the name, the name of the service, the timestamp, and then some field values to give you the data that's important for that particular application. You've got logs. In your logs, it's probably the second place you'll go, because with metrics, you can see what's happening right now, but you don't necessarily see what's happened. And so with logs, you can go take a look at what's happened, and then perhaps it'll help you understand what led up to the problem. And then there's distributed tracing, which you can identify where the problem occurred. So which service caused the problem, then go dive into that service and find out what happened, which is critical, because otherwise you're searching through all these logs and all these services. You don't really know what's happening. So if you interconnect all of these, then that's really going to help you understand what's going on. All right, so let's get into distributed tracing. Is this just a hype? Well, I guess that depends on if you believe in microservices-based applications. Because if you are using microservices-based applications, I don't see how you can go on without distributed tracing. So let's take a look, first of all, at what a monolith looks like and how an API call might happen through a monolith. Here we have a basic linear path from the client to the server and then to the database. And if an error occurs, you're gonna mostly know what's going on here, because all of your code is in that monolith. And you'll be able to see, once the call comes in your monolith, you'll be able to see the call out to the database. So if the database is causing a problem, you can set a timeout, or you can track the database issues, and then you can go look in the database logs if there's a problem there. So you mostly have everything that you need to discover what's going on. However, when you have a microservices-based application, then modern applications are based on microservices, and they can be based on many microservices. And so this can be very complex. This diagram is actually quite much more simpler than it might be in your real application. But here you can see how one service might call many services, and they might actually call multiple databases. And so to figure out where the problem is, you're going to need distributed tracing. So traditional tools may work here, but it'd be a lot of work. So this is kind of like a hop, multiple hops to map the request. And here you can see that service A is calling service B, something occurs, then service B might call service C, then you might get a response all the way back to service A, and the meanwhile service A is calling service B. And all these can interact with each other in different ways. They may be asynchronous. So you just don't know what's going on in one trace or one call. Okay. So what exactly is distributed tracing? So distributed tracing tracks the production requests as they touch different systems in the transaction. So as the API call makes its way all the way through the different services and back, you'll be able to track these requests. The requests have a unique ID, which is how you're able to track at the server. Once you collect all the data, you can look at the data in the distributed tracing server, and it will stitch it all together into one view, and you'll be able to see how that data moves, or how the messages move through your service or through your application. And so then you can that they call it like a trace diagram, and that's what you use to see what's going on. Or you can, from there, you can dive into maybe log entries that are related to it. And so these causal diagrams are much easier to understand than like scrolling through logs. In fact, you kind of have to look through, view them in a visual way. Okay, so why do you care? Primarily it's to reduce time in triage by trying to understand the errors, contextualizing the errors and the delays. That's the main thing that a developer or even an administrator might be using this for. You get to visualize, and picture's worth 1,000 words, right? So you get to visualize the data. You can very quickly identify where the problem might be, like where the time in your service is too long, or you're waiting for other services. And this gives you the ability to understand complex applications, like async code or microservices. It helps you see your overall architecture and see dependency diagrams, built from those traces. And, this is very helpful for different types of people. Before I forget, I want to mention that, DevSecOps folks, like the security folks, like distributed tracing, because as soon as you deploy a service, it's going to show up on the map as soon as it gets called, and that way they know they're not missing anything. Here's an example of some data that you might get from a distributed trace or a span. You might have tags that are going to tell you what's being called and what the actual query is. You have logs messages that you might be adding as well, giving you an error message back. You can add into it the span context, and you can see that the span data itself is not all that useful, but it gives you the trace ID, the span ID, and some other data that might be passed in. And this information is then used to stitch together the overall diagram. And here's an example of how the particular pieces of the distributed tracing work. You've got the parent span, you've got a child, and so the parent span might have the start time, the end time. The first span is usually called a root span, actually, and all the subsequent spans are generally called child spans. And then you've got the trace, and then you've got distributed context. So the trace is defined by its spans. The trace can be thought of as a cyclic graph of spans, where the edges between the spans are defined by the parent-child relationships, and this is kind of the whole string of connections. And then the distributed context is what binds them all together. It contains the identifiers, the ID of the entire string of traces and spans. And here's an example of what it might look like. This is a screenshot. I kind of forgot why there's doubling of everything, but you can see the each individual trace and span here. So before I go into a demo here, what I wanted to do is quickly talk about the application I'm going to share with you that collects all the distributed traces. And that is called Hypertrace. And Hypertrace it helps you make sense of all these API requests across all of your microservices. So it collects that data and then gives you a visual to interface to view and explore them. And it's basically, it's open source, but also it takes advantage of open source client libraries. So they could be libraries or they could be agents that are from many different open source projects, and we support them all. And therefore you can send all that data to Hypertrace. And in fact, if your application is already instrumented, then you can really just point it at Hypertrace and it should start working. Just like in a different database, you'd point to a different, an ODBC driver, you can perhaps point to a different database. All right, so Hypertrace really is for developers, of course, who are using distributed tracing to troubleshoot their application API calls, but it's also for application teams because you might be working on an application together, and this way you can see which team member is working on a service and maybe contact them, if something's not working right. It's also for deployment teams because they can identify if a new service or change is causing a problem. So you deploy and now you want to see what's going on, and you can see in the traces maybe where a change is impacting your system. And then also for infrastructure teams who can take an overall sort of 30,000 foot view and look down and see which services are performing unusually. Maybe one's faster, performing better than another, but maybe that's normal. And so that might not cause a red flag. But if all of a sudden one's behaving differently than it did before, that might cause a problem, and you might look into that. So this project, HyperTrace, was open sourced in July, and we have users and contributors from major corporations. So we're off and running, and we hope you will participate. But let's get into the demo. Let me switch over for a second and get out of my screen here and go over to, there we go. Oh, not that one. Okay. Right here. Okay. All right. So this project is called HyperTrace. You can go visit it at github.com/hypertrace, but you're going to want to go into the HyperTrace folder. So you can go /hypertrace, and that's the repository that we're using for this. It's actually made up of multiple repositories, but this is the key repository. You can go here and you can star this. If you like HyperTrace, please go and star it right up there in the right-hand corner. And there's a lot of instructions here for you to get started. However, I do want to also point out that we have a getting started guide at docs.hypertrace.org. So if you just simply went to hypertrace.org and you clicked on our docs, then you get here and you want to click on getting started. And there's two options that I recommend. One is using HyperTrace with Docker desktop, and that runs on Windows, Mac, or you can run it on Linux as well if you got the Docker engine installed. And you can also deploy it into Kubernetes, and that's down here at the bottom. If you go here at the bottom, you can see that there's instructions for deploying into Kubernetes. So I'm not going to go through all the steps of deploying it. It takes about 5 minutes, I would say. But I've already got it running for you, and let me show you what that looks like. Okay, so here is HyperTrace running. Now the data that is showing up here is actually based on this application called the Online Boutique. And this Online Boutique is a sample app that Google created really to demonstrate microservices on the Google Cloud, but it's a very popular sample application. So you might see it in other demos. And if you just go and take a look at a couple products and add them to a cart and then place an order, maybe continue shopping and buy a couple of other items, keep browsing, buy a couple another item, add to cart, keep browsing. No, let's go check out. So let me go check out. And what's happening is we're creating a lot of traces right now, and spans are generating. And so let's go and check out HyperTrace now. So if we go back to HyperTrace, then we can specify, let's say I want to look at data just in the last 15 minutes. And now we can take a look at the data here. And you can see that there's data showing up. And on this top dashboard, you're going to get high-level information that's really not specific to any particular service, but might give you an overall idea of how your application is doing. So for example, you'll see things like the latency and the error rate and calls per second, that kind of thing. There's even this nice little diagram over here. It kind of gives you an idea of, are things behaving the way you expect them to behave? Is this normal? And so, and you can see your top assets and top services, that kind of thing. All right, now application flow is probably the most interesting thing that's new and interesting about HyperTrace. It gives you an overall picture of what services you have in your in your application or in your platform, I guess. In this case, it's just an application. And what happens is when the trace data comes into Hypertrace, it actually takes that trace data and it improves it. It basically enriches the data by looking at IP addresses and other things to figure out, do these API calls all belong to one service? And then it's able to figure out what service is calling which service, and we can then figure out this diagram. And so there's a little bit of machine learning in here. This is a little advanced that you might not get in other distributed tracing platforms, and you can see it's very useful and interesting to see how this works. Now, in this particular case, you can see that this front end service, which is receiving it's probably the front end for the web browser, is actually receiving the API calls, and it's calling out to these other 4 services. And you can move these around if you'd like to make it a little bit more useful to read. You can see it calls these 4 services, and you can also see that the shipping service is also dependent on the checkout service, and the checkout service is Siri's calling me, and you can see that the checkout service is calling the product catalog service. All right, so, and then if you hover over them, you can kind of see that popping up. You can see some of the performance data. So, in this case, you can see for that specific service, and including all of the APIs inside of it, how is that particular service doing? You can see that it's P99 latency, any error messages, the calls per second, that kind of thing. All right, the total call count within that time. Notice it's all within this time frame up here. Okay. Okay, so let's take a look at, let's go click on a trace. Let's go click on the front end. And now what's happening here is if you click on this particular service, you can see that this service, how this service is doing. You get a nice diagram of all the services that it's calling. You can see its top endpoints. You can see the other information, latency about that overall service. You can also see the endpoints within it. So if I click on endpoints here, then you can see let me get back to where I am here, my notes. Okay, then you can see any of the endpoints for this particular service. And you can see that this overall view, by the way, looks kind of like the high level view, but it's not. It's specific to this particular service. And if we click on a particular trace, hold on a second here. All right, and we click on a trace, you should see, where is it here? Okay, I think I went too far back. Oh, hold on a second, let me go back up. Okay, so if you go to the front end and you look at endpoints, you can take a look at the endpoints. You can see the traces that are occurring. And you can see it's just kind of behaving a little bit strange right now. I don't know why. Let me go find another service because I somehow have had some trouble there. And we take a look at traces, okay? And there we go, okay. And you can see the details about that trace. And there's a lot of detail in here. So, there's a lot of information to look at. You can drill down really deep and see what's going on. And it's kind of an endless bottom until you get to the end of the flow. But again, so let's go take a look at front end here. And this service, and you can see that it has its own dashboard. I'm backing up here a second. And you can see the services that it's talking to down here. And you can see the details about each endpoint. You can see like the top endpoints and the health as well. So again, lots of information you can see here. And then if you click on endpoints up here, you can see all these different endpoints. And you can see an endpoint dashboard, and which is similar to the services as well. So you'll see kind of like it becomes very familiar to you. And this dashboard has all the data, but it's just for this particular endpoint. Okay, so take a look at this one. And then if I click on traces, and it's not really showing up that well here for some reason. But anyway, you can look at, for some of the URL, maybe the URL is just not visible for this particular trace. Okay. All right, so that's the application flow. And then within services, you have a service view. So if I click on one particular service, if I'm the service owner of that particular service and I want to see what my service is doing, I can just go right here, click on my service, and I get my own dashboard. So this would be different based on what type of user you are of Hypertrace. And again, here you can go down and you can click on endpoints, and you can click on traces, and you can see what's going on. Okay. Now backends is not as easy to track because some databases don't have just like some library to provide distributed tracing, but some do. Also, you can instrument your own particular service to recognize when it's called the database, so you can sort of add it into the view, even if the database itself is not communicating, sending the data out. So you can add in a backend. This particular application, the backends are not added in. And then there's the Explorer view. And Explorer view is pretty cool because this is sort of like an SQL playground. It gives you the ability to run some queries. For example, you can specify like a particular protocol that you want. And you can say, I want the protocol to be equal to HTTP, that kind of thing. And let's see here. And let's see, let's go ahead and refresh. Okay, and you can see below the different results. You can see here in this particular case, we're taking a look at a trace that's going on, and we're able to see all the traces and which calls that they're making. And you can really get into the details here. You can see the full trace if you want. And this is basically for this particular trace, everything that's getting called. And this is where you can go in and troubleshoot. So once you've found the problem that you're looking for, and or the service that's causing the problem, and the API that's causing the problem, in this particular case, it's a checkout API in the front end, then you can go down and look in all the details and find out, oh, this front end service is a little bit longer than it should be, or it's making too many calls to the database here. Perhaps maybe it's making a lot of calls to the database, and each one of them is adding up. So this really gives you the overall ability to find different problems that you may not have known about or been expecting. And you can, again, this is a nice view of the services, the API call, the endpoints, how long each one of them is taking. This is really where most people go in to understand what problems you might be having. You can filter by protocol, group by different metrics. You can change the duration, by the way, up here. Notice how I've set it to 5 minutes. Maybe you just want to see how things have been going overall, in the last 6 hours. Or maybe you want to see just in the last 15 minutes what's been happening. Okay, so yeah, you got a lot of flexibility here. And that's really about it for Hypertrace and distributed tracing. Again, I want to repeat that depending on your use case, what kind of user you are, you might be using this different. At the high level, the infrastructure type people just might want to see a high level view. How's the overall system doing? If you're a developer, you might go into Explorer and look for a particular trace and want to troubleshoot it. If you're a service owner, you might just always come here to the services tab, click on your particular service, see how your service is doing. You might have this up all the time. There are people right now that are creating a Grafana front ends for this, so you can view this in your Grafana dashboard as well. And I'm sure we'll have other different ways you can view all of this data. So let me go back to my screen here, just to give you one last plug give Hypertrace one last plug. So it gives you this overall view because it enriches the data and it's able to provide you views on your distributed traces that you might not be able to get anywhere else. There's pre-canned dashboards out of the box that give you the views for the services, the APIs, the backends. There's integrations, or we're working on integrations with Grafana and others. It's extensible if you want to build your own enricher. So let's, for example, say that you are focused very much on e-commerce and you want to have an enricher that specifically looks at perhaps your customers looks at traces by customer. You can perhaps pass in a customer ID and have a drill down view that's just filtering by customer ID. And again, this is interoperable with other distributed tracing client libraries and agents from Zipkin or Jaeger or OTel, Open Telemetry. We have a GraphQL API, so if you want, you can actually call the data through GraphQL and figure out your own way of viewing it and displaying the data. And just all the slice and dicing, the API analytics is very powerful. Please go check out our project. You can go straight to GitHub and check it out there. Again, I recommend that you go to hypertrace.org and click on the Getting Started guide. That's the best and easiest way to get instructions that will make it easier for you to install on your Mac or Windows or Linux as well. And we got a cool promotion going on right now that if you take a screenshot of Hypertrace running whatever application or even a sample application, get it up and running, we'll send you a t-shirt. We've got these new cool t-shirts. They're just being printed. Hypertrace, strap yourself in. I don't know if you get that reference, but it's from Star Wars. I think Han Solo says it when he's talking about the run. I forget the name of the place, but yeah. And we're also offering to help folks. If you have an application that you would like to instrument, if you think Hypertrace will be useful to your team, then we're happy to help you right now. So we're offering free help to instrument your application to send traces to Hypertrace. Again, these traces are also usable with other distributed tracing platforms as well, like Jaeger and Zipkin. So, we're not tying you into our platform. We're all in a big popular ecosystem now called mostly the Open Telemetry ecosystem. So if you're interested in finding out more, please join us on Slack. If you go to hypertrace.org and click on Get Started, you can go there. You can also go to, just go to hypertrace.org and click on the Slack link. And we're happy to help you get started. And thanks, that's about it for now. So if you have any questions, you can, again, go to that URL. You can also email me, happy to take your emails. You can follow me on Twitter at Dave Nielsen. And also there is face-to-face. So in the track 1 on Slack for AWS Community Day, you can go in there as well. And I'll be in the face-to-face in just a few moments.
Thank you, Dave. That was really excellent. Can I ask you a question? I don't know if moderators are allowed to ask questions. So Hypertrace is an open source project that's hosted on GitHub.
Yep.
And it's supported by Traceable, which is selling a distributed security product.
Yeah, so I didn't get into that. Perhaps I should have, just so you understand more about where this is coming from. Yeah, Traceable uses Hypertrace as its own distributed tracing platform. So we're using it in production. But our company doesn't offer distributed tracing as a service. We offer security for your APIs. But we require distributed tracing in order to do that. Like, it's built on top of distributed tracing. So we figured that, hey, this is really useful to us. Perhaps other people will benefit from it as well. And we put a lot of time. We're supporting it for ourselves, so it's continuing to get improvements. We're now getting contributions from other folks, and we expect that it will get wider adoption.
Thanks. Yeah, there's some great information on the traceable.ai website about traceability in microservices and I guess I'd call it a next gen application, web application firewall.
Yeah, yeah, something like that. We're kind of in a category of our own right now, but we expect to have company.
Yeah, well,
The
fantastic.
Yeah, and if you want to find out more about Traceable, I should have mentioned this as well. You can go click on the sponsors tab in the conference, the virtual conference, and there is some training over there. Actually, you can kind of learn. It's a short, not training. It's just this kind of a short overview of what Traceable is. So we're sponsoring the conference, so we've got our kind of sponsor over there.